Intelligent forming control technology for fastener manufacturing. Taiwan stands among the world's top 3 exporters of industrial fasteners, shipping more than 80% of its products overseas. This makes Taiwan a key player in the global fastener supply chain. However, the most critical factor influencing fastener production lies in quality control during the forming process. Fastener forming quality is now managed with smart machine boxes, SMBs, but 4 key challenges remain. 1. Frequent mold changes in customized production. In small batch customized production, molds must be frequently changed and fine-tuned. Even slight manual deviations can cause unstable forging force and quality fluctuation, making it difficult for AI models to learn and adjust automatically. 2. Manual inspection can trigger continuous scrap. Fastener manufacturing is a continuous process, yet most factories still rely on manual sampling. If defects aren't detected immediately, it leads to continuous scrap and wasted materials and energy, since forging is irreversible. 3. Fragmented carbon and energy data. Around 80% of fastener carbon emissions come from upstream raw materials. Reducing defects directly lowers waste and emissions, yet energy and utilization data remain scattered across systems, making precise analysis and carbon tracking difficult. 4. Cybersecurity risks in digitalized manufacturing. As production becomes digital, massive data exchange raises serious security risks. Once systems are breached, process data may leak. Conventional security software is hard to integrate with factory equipment, increasing maintenance complexity and management cost. Crisis also brings opportunity. IFCTFM with 5 core innovations. 1. Precision parameter intelligence. Custom vibration sensors monitor bearing clearance at the feed side, while pressure sensors track the mold end. Together, they define the ideal forming range and ensure consistent material quality. 2. AI-assisted forming optimization. AI analyzes waveform data from a few good samples to model the ideal forming curve and tolerance range. It automatically recommends parameter settings, shortening setup time, and reducing human error after each mold change. 3. Predictive maintenance intelligence. Through one-class SVM modeling, SMB detects early signs of machine abnormalities. A greedy algorithm estimates lifespan and failure probability, sending instant alerts to prevent downtime. 4. Smart energy and utilization visualization. Integrating MES and smart meters, the system visualizes real-time machine utilization, power use, and carbon efficiency, helping manufacturers optimize energy and productivity. 5. Data security. SMB uses multi-chaotic encryption with high-entropy random keys that can't be traced or predicted. A synchronized algorithm keeps data transmission instant and secure, cutting computing demand by 60%. IFCTFM has been integrated into forming machines and already used in Taiwan's largest fastener factories, and adopted by suppliers for high-speed rail, automotive, electric vehicle, and construction fasteners. Next, IFCTFM will extend these capabilities to die casting and stamping, creating a fully integrated AI smart cycle. Build industry resilience to face future challenges.